the new .NET platform with Richard Lander.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. And I'm, for one, doing a ton of online user group speaking still. And if you run a .NET or Azure-related user group and are looking for speakers, then reach out. I'd love to get on your schedule, and I know others who would as well. The sponsor for today's episode is ClearMeasure, and they are a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. So if they can help, please get in touch. And also be sure to check out the new video show, Architect Tips. I'll leave it up to you to search for that. Our guest today on the show is Richard Lander, and he's a principal program manager on the .NET team. And he's been at Microsoft for 21 years, 18 years of which has been on the .NET team. And that was since 2003, where the codename was Whidbey, if anybody remembers that. He works on making .NET work great in lots of places. For example, memory-limited Docker containers, ARM hardware like Raspberry Pi, emailing GPIO programming and IoT scenarios, and cloud native. He's also part of a design team that defines new .NET runtime capabilities and features. And he still enjoys British rock and Doctor Who. He grew up in Canada and New Zealand. And Richard, welcome to the show. Welcome back.
Thanks. Yeah, it's been a while since the last time. It's great to be back.
That's right. You were on episode 50, which is 2 years ago. So if anybody's interested, go ahead and go back to episode 50. But a lot's the same in 2 years, but a lot's different as well. You guys have been busy.
Yep. I'll tell you, at the start of or maybe for the first 6 months of the pandemic, it was pretty rough because a lot of people on the team got called in kind of like for, fireman or firewoman duty to help out other teams at Microsoft.
Mm-hmm.
A lot of the server teams, cloud teams use .NET, and they all of a sudden got hit by like all this load. And they needed their apps to work more efficiently. And the supply chain of parts was not super good for a while. So it's like, these are the servers we got. Let's make them work better. So a bunch of people stopped working on, quote unquote, like our features for the next version and had to go do that. So that's definitely slowed down for sure at this point. But that's kind of one of the things I think about from the last period.
That's right. I remember a time when all the software from Microsoft was shipped on CDs or DVDs or just direct download. And but now with Azure, there's whole service teams where the R&D teams are next level support because you're running so much of it.
Oh yeah, it's totally true. Like we have this like internal kind of support PagerDuty system, and we actually haven't been like completely pulled into that like Azure service teams are, but it's getting pretty close to being that way for the reason you said.
Mm-hmm. Now we talk for new listeners out there, we talk a lot about all kinds of different technology that fits into the .NET ecosystem and the Azure ecosystem, and how to properly set up development environments for it, build, test, deploy, all that. And the .NET ecosystem has the runtime, then the language, then the various frameworks. Just for people who didn't hear you speak last time or maybe new to the show, what part of that do you spend most of your time in?
Good question. I would say I spend most of my time. So I'm nominally program manager for the runtime. So I spend a bunch of time on that. But then I also spend a bunch of time with the folks that provide our like deployment and software acquisition story. So a lot of that's on containers, but basically, the last mile kind of the product is giving you installers and container images that you then pull onto your machine. So I spend a bunch of time there. And then I also spend a ton of time blogging. So I've done like most of the .NET announcement posts over like the last 10 years.
Mm-hmm.
And then, I've started a new series that I think we're going to talk about a little bit, these conversational posts. And so I spent a ton of time on kind of written communication to tell people what we've built.
Education is huge on that. We'll talk about that now because you're right. If people have been paying attention to the official announcement post, and they're familiar with your name because you've done so many. What's the vision with the new blog series?
Yeah, so my name has been at the top of all these posts, and on one hand, cool, that's a good thing, because they actually take a lot of work. But on the other hand, there's all these engineers on the team who put their heart and soul into these features, some of which I worked with them on, but it's not fair that their name never shows up on any of these posts. And so that kind of always bothered me a little bit. And so I've been trying to think about a new way of giving people on the team more visibility, also to kind of demonstrate, to give people more insight on the fact that we have like this first-class engineering team with, hardcore developers. And so basically I saw there's I think it's InfoQ. Is that the right one that I'm thinking of? They have this really cool virtual panel set of articles or posts. And I kind of stole that idea. And although I modified it a little bit and basically just came up with a set of compelling questions, invited people from the team to go answer them, and came up with this new series that satisfied these goals that I had, which is to bring more visibility to the people and to some of the hard problems that we work on that aren't necessarily topics you would cover in an announcement blog post. So I had really good feedback on that, and they've been super fun to work on, these posts.
Yeah, and you've got conversation about diagnostics, containers, the .NET type system, .NET interop. There's a lot of topics which could go really, really deep, each one of them.
Yep, and we've got several more coming. Like, for example, one of the ones that's coming up is on like .NET streaming APIs. Another one, we're going to take a bit of a shift and talk about dev skills. Like, what are the skills that people have on the team and how do they use them, as opposed to talking so much about the product. Yeah. So lots of good stuff coming.
For sure. And we'll include the link to that blog series in the show notes for your listeners. Now, one of the things you've been thinking about lately is platform and OS enablement, and of course, Apple Silicon has kind of been big news lately. What are you guys doing on that front?
Yeah, so we basically have a model where we need to support .NET in all the kind of at least desktop and server kind of operating systems that our customers ask us for. In .NET 6, we're definitely expanding that to mobile, as well as we unify in, the Xamarin and Mono workloads. And so back, a few years ago, we decided that Linux ARM64 was something we needed to go add, and we did. And then, Windows ARM64 came next, and we added support for that. And those were actually somewhat straightforward. And we actually got some help on that. There were some companies in our ecosystem that were also interested in both ARM32 and ARM64, and that was super helpful. Samsung and Qualcomm are the two that I'm thinking of. And then so Apple Silicon came around, and that was actually a bit of a heavier lift than we were actually it much heavier lift than we were expecting. So the two main aspects of that were clearly there was the ARM64 aspect of it. That was actually fairly straightforward, but then there were two heavier duty parts. One is that there's some additional rules for Apple Silicon that like Linux ARM64 doesn't have. And specifically what that is you can't have memory pages that are marked read, write, and execute. So they have to be marked either read, execute, or read, write, but never the combination. It's the combination of write, execute that is really the bad one. And so we had to do work across multiple parts of the product because some parts were reliant on these like very kind of liberally permissioned, if you will. They're not technically permissions, but liberally permissioned memory pages. So that's a heavy lift that's done. And then the second part is x64 emulation has become a new scenario. So we've had, like, for example, 32-bit emulation on like Windows machines for like over 10 years, 15 years. But the OS gives us quite a bit of help there. So, you've got the whole syswow 64 layer, you've got a 32-bit command prompt. And so when it makes it easy as a software provider to kind of reason about that. Well, with x64 emulation on both Apple and on the new Microsoft ARM64 OSs, the x64 emulation is really just a chip feature. And there isn't like a 32-bit program files type thing. There isn't a command prompt. Sorry, there isn't a x64 program files, and there isn't an x64 command prompt. And so as a result, we need to do more thinking about like how to have x64 and ARM64 coexist at the same time. And so that ended up being a significant project as well that we're still in the process of. So those are the sorts of things that we have to deal with to try and provide a seamless experience on new platforms.
Well, that's encouraging because as opposed to having to, at a minimum, recompile, but really, re-engineer your product for these different targets, that sounds like existing applications will have a chance running on these new platforms.
Oh yeah. Once we're finished all the work, the amount of effort that the average developer will have to, exert is quite minimal. In some cases, basically zero.
Nice. And being a Microsoft platform developer now for 24 years myself, that's one thing that the company has consistently done well is backwards compatibility. It's really been kind of amazing, these different transitions that have happened over time.
Yeah, I mean, it's definitely part of the Microsoft DNA. I try and be pragmatic about that. Like, certainly in some cases, you can hear stories about changes that the Windows team made to deliver compatibility to 99.9999%. I don't think that's the right place for us to sit because we have this side-by-side product at this point. So we got to take some advantage for that.
Yeah.
And make sure that we're not having this super Byzantine type approach to compatibility and that it becomes a problem for innovation. So, I always start with what's the innovation plan that we want to move forward with. And then if there's a compatibility issue, how do we kind of shave off those hard edges and make a pragmatic choice while still putting innovation as the top thing? Because often with these breaking changes, sometimes it's well below 1% of people that are going to be affected, where the innovation change could affect 100% of people in a positive way. Right.
Now, you've been working on, I think, the last in-person Ignite conference, if I'm correct, you had a really interesting demo with an IoT system that did weather and ran different boards and had Raspberry Pi components. And what's the current state of the art in the .NET IoT space now? What, a couple of years later?
So yep, I did that, or my team put that demo together. I guess I would say, in some ways it's not super different. The big effort that we've been doing in IoT land, say the last 6 or 12 months, is making it so that the community can be kind of more active in that particular project. So, like, for example, one thing that we started during the pandemic that we hadn't been doing before is we've got now a weekly triage meeting where we go through all the issues and pull requests that the community has made. And that's been kind of our major focus, is unlocking the innovation within the community. We even actually have 2 people on that call that aren't even actually on our team. One is another Microsoft employee who's like completely not even in our division, some completely other different part of Microsoft. And then one is a person from the community, who calls in every week and helps us, and both on the kind of triage process, but also contributes changes. So, like, one of the changes that we've been working on together is this like board abstraction PR. And so it's to make it so that the code that's in, like, it's easier to port .NET IoT to other boards and have them light up, as opposed to like having all that knowledge be hard coded in one place in the repo and kind of hard to change.
Mm-hmm.
That's the main thing we've been doing. Me personally, I wrote a couple of blog posts during the last 6 months about IoT stuff. And I've got another one that I'm working on. The first 2 were about LEDs. But like the main focus wasn't the LEDs. It was actually on the multiplexing systems that you need to use in order to light up multiple LEDs, and they can be used for other things. So like shift registers, for example. And so the post that I'm working on right now is how to like light up small LED matrices. So it's basically LEDs again, except 2-dimensional, arrays of them, and matrices. And making it like, my goal with all these things is like, how do you write one bit of code that is like the logic of what you want the thing to do, either words going across an LED matrix or images, but how do you make it so that code can work across any LED matrix that you buy, and then across multiple multiplexing schemes? So like there's a bunch of really good, like there's like the Max 7219 chip that people use, and there's this other one whose name I always forget. It starts with H, HTK something, and like under at the base, those APIs are quite different. But if we can extract them up, then it doesn't matter which hardware you buy from, like Adafruit or SparkFun or Alibaba or DigiKey. It's like, just have this one bit of code. You'll talk through this interface, and then all the right things will happen underneath the covers. So that's the sort of thing I like to work on. And .NET is super well positioned for that because of the type system that we have.
Yeah. A couple episodes ago, I interviewed the leader of the new Terminal.Gui project, which was started by Miguel de Icaza, and he mentioned that as a user interface for memory-constrained IoT devices, being a console interface. And so I didn't know if that was just a side project, or if the actual .NET and IoT teams had any conversations about that.
So I do talk to Miguel. We have not discussed that that particular thing. We did actually talk to Miguel. This is now going back like 2 and 3 years ago. In particular, when we were figuring out what we wanted to do for LED matrices, we were trying to figure out what we wanted to be the underlying data type. And, should we go with bitmaps, or should we go with span of bytes, or span of color, or we were trying to figure that out. And part of the conversation is if he had some terminal system, you could actually imagine rendering that same underlying data type to a terminal. But that conversation didn't go very far. Okay. Maybe something to reconsider again.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Now, with all the different IoT devices out there, with Maui and Xamarin, there's so many different smartphone types to have to test against and run against. What's the current method with IoT devices? Is there any kind of built-in testing capabilities, or is it still the set up your own test lab type of situation?
It's definitely closer to the second one. So, for example, like the way our own system works is like when you make a PR against the IoT repo, we have a bay of IoT devices in a lab somewhere. I don't even actually know where it is. Mm-hmm. It's not in Azure. It's in a room somewhere that we maintain. And our team built some custom PCBs, which is a hat on top of a Raspberry Pi. And then we've got a couple different...
I'll be the acronym police. The PCB is printed circuit board.
Yeah, printed circuit board. Pretty much any device you have has a electronic device has a PCB mm-hmm. in it. It's that green thing. So we have a couple pieces of hardware that are uniform across all these Raspberry Pis, and then it enables us to test. Like the thing we're focused on is actually less the devices and more the protocols that they support. So it's like making sure we've got one device that does I2C, another one that does SPI, another one that's more GPIO oriented. So it doesn't matter what these acronyms mean. They're basically the low-level serial protocols, like the S in SPI stands for serial. Actually, I think that might just stand for serial protocol interface. I'm not sure. But they're low-level serial protocols that enable you to talk to different devices, and some of them have daisy chaining capabilities. And it's just so, yeah, whenever a PR hits the repo, it's making sure that none of that stuff breaks. But it's all custom stuff that we had to set up. There's no good system.
Nowhere close to that being a productized, hosted agent type. Here's the Microsoft system on a chip test bay.
Well, no. And I mean, because the problem is like on one hand, the Raspberry Pi is just an ARM computer. So, in imaginary land, we could imagine it's like, the Azure Raspberry Pi service. But the problem is as soon as you start to think about the pins that are, the whole good part in my mind is all these GPIO pins, which stands for general purpose in out on the Raspberry Pi. And then as soon as you think about using those, then you get into custom land.
Yeah, now you're
immediately like it could do anything. Engineer. Yeah.
Now you're voltage and soldering iron and all that.
Yeah, so you can't build a service.
Yep.
Out of that. It's crazy.
Now, before we run out of time here, you've also been doing a lot of work on cloud native with containers. And we've had a lot of guests kind of give us an update on the state of .NET and containers and Windows containers versus Linux containers. So I got to ask you, like, what is the state of the art for people just doing regular .NET applications? What should they be looking at these days?
Yeah, so there's a team of 4 of us that are like, the people building the container images for .NET for Windows and Linux. We just had our stand-up meeting a couple hours ago for the week. And I guess I would say this is pretty much any, ASP.NET developer that we talk to that is doing cloud stuff, they're using the container images that we ship. They're incredibly popular. And we take that responsibility incredibly seriously. Actually, one of the things that I have ended up doing, not intentionally, is the thing that's most confusing to people is like CVE management, which stands for, I think it's like common vulnerabilities, E, whatever the E stands for. Basically, just it means it's a formal way to describe software vulnerabilities.
Then it probably stands for exploitation, perhaps.
Yeah, probably, yes. Common vulnerabilities and exploitations or something. And, there's some US government organizations that maintain these databases. And I actually think that's like a super important thing for the government to be doing. So thumbs up on that one. But yeah, so where was I going with that? So I ended up talking to customers about how to manage these situations, and I've written several blog posts about it. And so that's a thing. But we have a build system that, when we see that there's been an update in, say, Ubuntu or Alpine or Debian, those are the 3 Linux container container OSs that we support. We check every 4 hours to see if there's been a new image, and then we do same day publishing. That happens automatically. It happens when we're sleeping. So if there's a patch update for security in Linux, we've pushed new images to the Microsoft Container Registry same day.
Nice.
And it means we're doing our part to keep you safe. The other thing is that after doing container images now for several years, we've made changes to support, say, Docker memory and CPU limits. That was kind of a thing a few years ago. We've kind of got a good story there. And then more recently, we've been thinking about producing, like the .NET that we produce. It's intended to work all the way back to, say, Windows 7 on one hand, and Ubuntu 16.04, and it probably still works on 14.04 too, although we don't support that. But the backwards compat, back to that topic, is pretty broad. And so we kind of had this realization of like, I don't think people use Windows 7 in the cloud for hosting web apps.
Yeah.
I don't think people are using Ubuntu 14.04 anymore for hosting web apps. And so we thought, we can scope, like we can basically make some mini breaking changes of a sort, and I'll explain what I mean by that in a sec, that basically make the container images that we ship the best that they can be. And by breaking changes, I mean is we don't support CPUs that were built 15 years ago. You have to be using a CPU that was built in the last 5 years.
Mm-hmm.
And basically, if you're hosting in the cloud, that the chips that they are hosting are quite new.
Yeah.
And so we can exploit the features that are in there, and other things. So that's what we've been thinking about. And the first kind of down payment on that is going to come in .NET 6. We're not quite done that. We're still very much working on this vision, but I'm hoping that the first changes on that path are in .NET 6, and that we can say, like, .NET 6 container images are way faster than .NET 5 ones because of these choices we made.
Well, you said that practically everybody developing a web app and running on Azure is using the containers. Now, if someone just deploys to app service, are they using those containers under the covers anyway?
Great question. It depends. If you're using Windows, then no. Then they're giving you a PaaS hosted service, platform as a service website, and that's totally cool. It's not like we're trying to convert everyone to containers. We don't have that that goal. If you're using their Linux offering, then I believe that you're using containers. I'm not an expert.
Okay.
And like, we talked to the Azure Functions team as well. They have a container hosted offering. Certainly if you're using like AKS, Azure Kubernetes Service, or ACI, Azure Container Instance, then you're definitely using containers. So we just see the momentum is definitely on containers. And I'm not here trying to convince people, like, if you've got a model that's totally working for you, then I'm not telling you go use containers. What I am saying is that our team is like super focused on building a great container offering because so many people are using that modality.
Now, for someone who's building new applications, and certainly with Blazor's been out for now well over a year, and Maui's coming out, and so there's lots of new applications that are going to be written. So people are going to be making these decisions fresh. They won't be held up by a legacy application or anything like that. So they're going to be asking, okay, with all the current offerings, pros and cons for normal business applications. I'm not talking about Domino's.com that has to scale for Super Bowl Sunday or anything. I'm talking about, hey, I know all the people in my company. I kind of know my scale level that I need for normal business applications. What's your prediction? What do you think is going to be the most general purpose runtime in Azure for just these regular, Blazor applications people are all starting to build?
Yeah. So I think, what I think is going to happen is, and it depends what you meant by runtime, but
app service, ACI, AKS, all the different ways, same application, but you could run it all these different ways.
Okay, I got it. So I think what's going to happen is, like, right now, Kubernetes definitely has a reputation of being pretty hard to adopt for mere mortals, and I think that's true.
And for experts, not just mere mortals.
Yeah. So I think what will happen is you're going to start to see some higher level services, and this is certainly not an announcement, but higher level services that basically give you all the benefit that, say, Domino's.com could have with smart people. Like you can be a mere mortal, get all the scaling, it's containers underneath, and whether it's AKS or app service or whatever that's offering that, I have no idea. But the basic idea would be that it's container based. And the reason is because containers offer a standard interface between you and the service. They don't need to know the difference between Java and .NET and Go because it's a standard interface. Basically, there's an entry point that the container defines, and the container hosting service knows how to launch the container, and the entry point gets called. So that's super, super valuable. The other thing is, like, there's this concept of environment promotion. And the basic idea is, one environment is my dev machine. Then we've got like some like staging and testing and prod, and maybe multiple rings of prod. And the container image that I produce stays constant as it gets promoted through those environments. The files don't change, but then like environment variable injection is actually super easy with containers. So basically, as you go through those rings, you can give the container image access to like different certs, different secrets, different Azure storage accounts, and it starts to light up. But you like get more and more confidence about this new update of your app because as it goes through the rings, the app doesn't change. So I think those things are super, super valuable.
That's a good point. Yeah, if you know that none of the files, it's literally impossible for them to be any different than the previous one, then it narrows down what could be different to environment variables or maybe the firewall rules that happen to be there, a smaller set of things.
Yeah, exactly.
Nice. Yeah, it's definitely, again, interesting time to be a developer for sure.
Oh, yeah. Yeah, absolutely. Like, I think about, back in the 90s, if you wanted to like have your own domain name, and like email server for that domain name and web server. It'd be like, how would I get that? Do I have to do like colo in a data center somewhere?
Right.
And now it's like so simple.
Yeah, it absolutely is. Yeah, I'm sure you were too. One of the weird ones that had their own customized email address.
I still do.
Yeah, I was. Well, way back when you were odd if you had an email address of any kind. Like email, why would I do email? So.
Yeah, I remember those days.
Well, now the current generation of developers is, who would ever not have a smartphone? It's that kind of thing.
Yeah.
You mentioned that you want .NET 5 and 6 to be the fastest experience on containers, and at the Build conference, there was some announcements about .NET 5 and C# being, was it the fastest, or maybe it was the fastest mainstream execution? Well, do you know what the status of that is as far as just speed?
Yeah, I think I know what they're talking about. So the last, basically since .NET Core 1.0, we've been focused on this Tech Empower benchmark, and possibly to a fault, but we actually have a really good relationship. Tech Empower is not Microsoft. There's no like weird relationship between the two outfits, two organizations. That said, we do have a good relationship with them. And we use the same hardware in our lab that they use. So meaning, both the same hardware, the same size of network, like, 10 gigabit switch or 40 gigabit switch, whatever it is. And so it means that when we get results, we have high confidence that they're going to replicate in the Tech Empower's lab.
Sure.
So that's all good. And so we basically just assigned, whole groups of engineers over the past 7 years to focus on how to make that particular benchmark go faster.
Okay.
And I believe in, one of them is plain text. And I don't quote me on this, but I believe ASP.NET may now be the fastest framework in the Tech Empower benchmarks for that now.
That's what I thought I heard, which for a while there were some esoteric frameworks that nobody really used for business applications. Yeah. But with .NET Framework, it used to be where, it was kind of slow and sluggish. Well, now .NET Core, you go with .NET Core, and it's kind of like the king of the hill for performance now.
Yeah, well, yes, yeah. I want to make sure we're not over marketing this. So, there's lots of benchmarks that can be written. So I don't want to suggest that .NET's the fastest at every single one.
Yeah.
The main thing to focus on is, yes, we're the top of some. We're in a good place in many. Like if the thing to look at is the composite. Tech Empower has this composite benchmark that basically takes all of their benchmarks into one and has some kind of average of sorts across them. And so you'll see that ASP.NET Core shows up in a really good place. It's certainly in the top 10, not the top 5 for that. And, there's the other thing is that there's a culture on the team on performance. And so it's not just the fact that, it's like, we need to be number one on Tech Empower. That's just a way to focus the team on something and get them excited.
Right.
And if you used .NET on the server, you're going to be happy with the performance. Like you'd be surprised with some of the customers we have, both at Microsoft and in the rest of the world, some of the crazy things that people do in terms of the numbers that they're trying to hit. It can be throughput. We need to hit this number of requests per second. It can be latency. We need our latency, P99 latency, to be under a certain number. We need a non-allocating, every request to be non-allocating after we hit steady state, stuff like that.
Yeah. Awesome. Well, hey, Richard, I appreciate you coming back on the show. Lots changed since we had you on last, episode 50. And we'll make sure to include the things we talked about in the show notes and the blog series. But hey, this is a lot of great information, and thanks for continuing to push the .NET platform forward.
It's been a real pleasure to get to tell the story again on your show. Appreciate it.
Awesome. Thanks so much. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.